Hi, and welcome back to Edge-CGI. My name is Eugene, and in this tutorial we're going to take a look at how to do a topology inside of Zbrush compared to how to do it in Maya. This is the second part of the multi-part tutorial in which we create a simple game asset. We walk you through all the stages of asset creation. This is stage 2. We are going to take to see all the advantages and disadvantages of both methods. Only thing I would note, if you're familiar at least a bit with the ZBrush workflow, you probably know that it projects normal map between high and low subdivision levels within a single tool, where a lot of different applications such as Maya project between different meshes. Now for gaming, game asset creation, this second method is probably going to be better, but we'll utilize some of the ZBrush projection tools anyway to get more precise low poly mesh. All right, this is the model that we ended up with in the end of the previous tutorial. Now, the one that we had in there was around 11 million polys total, and that's way too much to use inside of the video game. So I went ahead and I decimated it. I merged all the subtools and decimated it with the decimation master. If you want to know a little bit more about it, I can refer you to Pixelogic website. It describes the usage of the decimation master in depth. There's just no need to cover it here. I mean, it's available online anyway. So this one is down to around 1 million polys. Still too much to use inside of the video game engine, but it'll be a lot easier to work with both inside ZBrush and Maya. Now, as you can see, this one is merged, so it will be easier to retopologize the entire model with all the details in there. We need to get ourselves a Z-sphere to start with. So, okay, so we have 1 million polys here. Let's go and let's see, it's one subtool. Let's go inside of the inside of tool menu, get ourselves a Z-sphere. Now, let's scroll down here to rigging and click select mesh and select our X. Now the next step, I want to scale this Z-sphere down so it will be inside of our mesh and not stick out. That's an important part because otherwise the topology will not produce correct results. Then I click Edit Topo in Topology submenu, and if you just click on your model, let me just, okay, why is it not clicking? Okay, so we need to be in a draw mode. So click, you can see this red circle appears, that's vertex. You click next, there's an edge between them. You click and create the next vertex, next edge, and if you come full circle and close this loop, you'll get the poly, a poly. Okay, so if we continue clicking, you'll get more polys, and as you can see, it continues drawing from this where the red circle is. So you can see every new vertex is red circle now. So what if we want to continue drawing polygons from down here? We need to select Move tool and select these vertices that we want to start drawing from. Now Move tool not only works as a selection inside of the topology process, but you can also move them around, and it's brush size dependable, so smaller brush scales will show smaller amount of vertices around, and bigger brush scale can move several vertices, whatever is inside of the radius. If we hit A on the keyboard, you can see the preview of our new topology, and basically that's just adaptive skin preview active here. As you can see, here it is. There's density slider, so if we scroll the way left here, that's exactly the amount of polys that we've created, but you can step up and down to subdivide that. Now the other thing while working with retopologies, sometimes you'll need to disable local transforms because by default sometimes it just focuses on that little sphere that we've scaled down. And then another thing is projection. Now I have it, it's the lowest menu there. If you have it selected, you can use the density slider to go up and down, and the resulting mesh will be a lot closer to what we have here while retaining the topology that we give it. Hope that makes sense. So I'll be using some symmetry here because essentially it's symmetrical radial for now, and I'll just start clicking and creating our new topology. So let's see. This part is sped up because topology process is basically it's pretty boring, and a lot of people try to skip it. A lot of people just hate it. It's not artistic, but here's a piece of advice that I can give you guys, at least the way I approach this. Try to think about it as a puzzle. Like there are things to consider when doing topology, and if you think about it as if you were solving some sort of a puzzle on how to how to lay out everything, that it makes sense, that it animates well, that all the details project correctly. So if you kind of follow this instead of just mindlessly clicking, this will be, well, I can say it will be a fun time, but at least it will be a bit less boring. So one of the advantages of doing the topology inside of ZBrush is it supports symmetry compared to, say, Maya, that we're going to take a look at a little bit later. You can use all the things that ZBrush has to offer in terms of transformations, such as radial symmetry and X symmetry, Y symmetry. I mean, for example, like you can see right now happening on the screen, this entire part that is round in shape, I can just use circular symmetry with 8 sides to sort of effortlessly create a polyflow that is just like encompassing the central side of the axe. Now on the blades, a little bit later when we come to that part, I'll be using I'll be using X symmetry as long as Y symmetry. I'll be using them at the same time because essentially the shape overall is somewhat symmetrical in both axes, but even though it's since we've deformed this a lot in previous video, it has regularities, so the topology itself that we laid out that is symmetrical kind of will pass through some of the parts of the geometry, and that is not too accurate. But the cool thing about ZBrush, about the whole topology process in this application, is that you can also have, like, we're using the projection, right? And we're not going to be using the real projection, like project all the subdivision levels and all the details throughout, onto the mesh that we're getting here. But we're going to be using projection nevertheless for the very first subdivision level. I'll walk you through that just in a minute here. But the cool thing about that, it will help to kind of erase those errors that might come from using the dead, just blatant symmetry here. It will kind of shift everything towards where it is on the original mesh, which is really cool. So it kind of speeds up the process. The couple of things that we gotta like, that I personally don't like, and I think they're objectively not really good, is that when you click and create new vertices on while creating topology, ZBrush doesn't really snap those vertices together. It kind of approximates them, their position relative to one another, and sees if they're close enough. Then it will assume they are the same vertex and create a poly there. So sometimes when you preview your mesh by hitting A on the keyboard, you'll see that you'll have holes in your mesh, and sometimes it's really unapparent where those come from, because seemingly, by all means, the polygon should be there, and that comes really usually from vertices not being approximated well enough by ZBrush. It kind of sees them as not touching, and you have to shove them around, kind of move them, and see if it changes anything. Sometimes it takes deleting some of them and readjusting them again. Now the other thing that is really hard to fight at times is that there's this thing happening sometimes when geometry kind of folds onto itself, and there's no way to kind of get rid of it with the topology. So I mean, nothing works. You readjust points, but that particular area is still sort of like almost like folding in on itself, and that may cause some errors in projection later. So we're almost finished here. All right, so here's our new topology. We're on the preview level of 2 right now, and this is pretty close to the original mesh because we had the projection on. Right now we're in density 2, and if we increase this slider here, you will have more details projected. It's sort of like adding subdivision levels to preview mesh here. Now it says projection in progress here. It takes a bit more time. So if you want to go all the way to the right and project the max amount of details, I recommend doing that gradually, one step at a time, because otherwise it can crash your ZBrush, and if you haven't saved in a while, it will, you'll lose your progress. So I'm going to try to do that now. Okay, so I've paused the video because I was afraid it will crash everything. So I've managed to do that to increase the density to level 8 without crashing anything, which is achievement. If we click a make adaptive skin here, it will create a new tool from from the new topology with all the projection. If we go into geometry tab, you'll see that it retains all the 8 subdivision levels. You can get more if you want. There is a thing here though. I wouldn't recommend using this process to actually creating a game mesh. Now I'm just doing this for the sake of demonstration right now. Because Zbrush sort of creates normal maps as from the difference between lowest and highest subdivision levels. So what it does is just takes all the information from the highest subdivision level and projects it to the lowest one. But let's see, if we zoom in here, you'll see that like some of these details are projected better than I thought they would, but some, you can see that these guys kind of have errors here. Now this might happen because the details that on the underlying mesh were out of the projection range. Let's go back to the original one here, into the projection menu here, and we have a couple of sliders like strength and projection range. Now if we increase projection range, these guys down here might actually get inside of the range and project correctly. But what will happen is we have some overarching geometry here. We have details like these elements here that kind of overarching on top of one another, and the projection will just inverse the resulting mesh, and you'll have to eventually resculpt this. So it's resculpting either way, and this is why I would recommend a projection, but only using that when you're subdividing, but only using that on the first subdivision level. So first level of density. This way we'll get our low poly mesh as close to the original mesh as possible with the projection and everything. It will kind of shift and adjust what you have to what you had before, but without all the errors, because the resulting mesh won't have enough poly density to support those errors, if that makes any sense. Which raises the question, how we're going to be creating a normal map if we don't have all the difference in between subdivision levels. Well, the alternative method, and actually the precise and good method of projecting a normal map, is not between subdivision levels as ZBrush does it, but between different models, different meshes. You have your low poly mesh and you have your high poly mesh, and you just project your high poly onto your low poly and you get a normal map. And you can do that in applications such as Maya. You can do that in XNormal. You can do that with Substance Painter. A lot of applications actually support this kind of projection. So we're going to be using that eventually, and we'll do that in Maya. But for now, I want to take a look at a different way of doing topology. So we'll grab our decimated mesh that we started with this time and load it inside of Maya and see how we can retopologize in there. Alright, here we are in Maya. The process is going to be fairly similar to what we had in Zbrush, but a lot less painful. So here's our decimated mesh. I've just loaded that in, imported that. What I want to do is I want to make the surface live. So let's see. We need to start with finding modeling toolkit first. let's go step by step. So let's find modeling toolkit. Here it is, and you can constrain what you do with modeling toolkit to a surface. Here is a nice thing called quad draw, which allows us to draw quads on top of the surface. So let's make this live. Now, no, wait a second. Before we do that, let's go into the layer editor, create new layer, and add our mesh to this layer so we can lock it in case we need that, or make it invisible later. Alright, for now, let's unlock it there and make this surface live by pressing this magnet button. Go back to modeling toolkit, and you can see it now says transform constrained live surface. Now let's go back to quad draw, and the way it works is basically the same way as in Zbrush. You just click to create vertices, hover shift click to create a poly in between those vertices. You can move them around and create new polys that will stick together, they will snap. Couple of things, a couple of disadvantages to this method is first, it sometimes it's hard to see what's going on. You can see the new mesh kind of goes through the previous one. So at some point we'll have to utilize the X-ray here. Where is it? There it is. With X-ray it's kind of easier to see, but when we have a lot of new topology, it will be kind of harder to make out what's going on. The other thing is that quad draw doesn't support any symmetry. There is a symmetry in modeling toolkit, symmetry button, but it doesn't work with quad draw. So you'll just have either copy it over or just do everything. Now the other cool thing is that you can create whole edge rows where you can just extrude them with tab, middle mouse click, and drag. And if you just scroll down a bit inside of modeling toolkit, there's a little shortcut reminder there that you can just refer to and see what other shortcuts you have inside of quad draw. Alright, so this part is sped up as well, and it takes a little bit more time than doing the same thing in Zbrush, but there is a major advantage here. There are several actually. Like first, all the polygon and vertex controls that you expect from Maya is still there, so you can easily access certain points, move them around. They will stick to the live surface, and it overall is less painful process than in Zbrush. Now, Maya does not try to approximate the point position, the vertex position, but instead it literally, with quad draw, it literally snaps them together. So if you grab one vertex and you move it close enough to the next, it will just snap it. Almost like welding, like there's Maya instrument that's called target weld. So it almost works the same way. Speaking of target weld, sometimes it's necessary to use that because in some situations, vertices that you're trying to snap won't snap together because maybe they may interpenetrate the original topology, and it drives Maya crazy, doesn't know what to do, so they will not snap. You can force these things on the new topology, so it's a great advantage that we can use all the Maya instruments. And there are a couple of neat things. Again, I can refer to you to the if you scroll down the modeling toolkit with quad draw selected a little bit lower, you'll see that it has a it's like a list of short keys for all the commands. Now, some of them, it's kind of extensive. There's a lot there, but some of the most useful ones are, tab, hover over edge, and then click drag will extrude the edge. Tab, hover over an edge, a middle mouse click and drag will extrude the entire edge loop. Shift click onto the edge will insert an edge loop, and control shift click hovering over an element, edge or vertex for that matter, or poly will delete it, and so on and so forth. So I mean, it may be complicated at times. You gotta get used to it, but overall it's really useful. And the cool thing is that you can sort of as you may have seen, I've created a set of long polys on the round part of the X, and then I've just inserted the several edge loops, and they snap. They actually snap. When you insert them, they snap to the underlying geometry, which is really good. And we can expect the mesh, the resulting mesh, to be pretty close to, in terms of surface flow, to the original mesh. There can be some, like inconsistencies in there, but that happens when you're doing your topology anyway. The important thing to keep in mind when doing any kind of free topology work is that you have details in your high poly mesh, right? And you have to somehow support them, because the way you probably are familiar with how normal maps are created, but if not, basically what happens is that it sees two meshes and then it projects the details. Like you may have seen, if you work in Maya or Max, there is a thing called smoothing groups, or in Maya it's edge smoothness. It's basically like how smooth polygon appears inside of the mesh borders. So if everything is smooth on your mesh, so anything inside of borders will appear smooth. And you can harden some edges, you can smoothen them. But the thing is, these are basically almost work like a normal map. Like normal map allows you to map the edge smoothness of a higher subdivision mesh, and it will appear as if everything is rich with details and smooth. But the thing is, you have to support those details. So you have to keep in mind that like we have some bolts on our mesh, right? So they will just appear as if we do not support them with details, then if we look at grazing angles at the mesh, they will appear flat, just an illusion. So to keep the illusion that the mesh is really high resolution, you have to be mindful about where you place edge loops and how you support the all the details in there. You don't have to support all of them, and if you're trying to keep if you're on the poly budget, with contemporary gaming engines, the poly budget is not all that important. But lots of times when you're trying to support all of the details, or you're not compromising enough, you'll create additional edge loops that are not necessarily have to be there, and overcomplicate your low poly mesh. And so it's a good idea to just think about what you can compromise and what you have support, and if not for poly budget, then for common sense, and for keeping it manageable. Because at some point you'll be UVing this, will be UVing this mesh, and for texturing and for all kinds of work, and to be able to make sense of what's going on, and to be able to unwrap it in a meaningful way, you have to keep your topology, keep it from going crazy, basically. So as you can see, right now I'm just doing the other side of the blade, and it's a major disadvantage of doing doing the topology in Maya is that it doesn't support symmetry. There you can see that there is a symmetry option in Modeling Toolkit, but it doesn't work with quad draw, because that symmetry option relies on mesh being at least symmetrical. The way it works, if you have somewhat symmetrical mesh, then you can target elements symmetrically. Like you have same sets of points on both sides, then you can enable symmetry and move these points around at the same time. So with quad draw it doesn't work, but it's not a big deal, especially if the mesh is not really complicated. You can go ahead and just manually do the other side. So here I'm trying to figure out this lower part here. This is one of the compromises I've been talking about, where it's the topology that I'm creating doesn't really support this detail, but we have to compromise here, because probably the player is not going to take a really close look at this part, because it's just like inside some sort of like overfolding geometry. So we can probably skip that and just just cover it somehow. Now we're almost there. Let's just inspect it for some holes here, and just use standard Maya instruments to close those holes. Those are just square polygons polygon holes. So here it is. We're done with Maya topology. As you can see, it's a pretty valid way of retopologizing everything, and you can get a game-ready mesh just like this with using QuadRAW. So both of these meshes are ready to be UV'd. As you can see, Maya's mesh might be not as precise because we didn't use projection. We just kind of winked the points and just placed them onto the underlying surface, so some parts might be not as precise in ZBrush. That's it for today. Make sure to stick around and watch other parts of the series. In the several next parts, we'll be creating UV unwrapping, we'll be making normal maps and creating textures. Eventually, we want to get this to work with PBR rendering inside Unity. If you found this video informative, make sure to share, like, and subscribe. And thank you for watching Edge-CGI. I hope to see you soon. Bye.